All right, welcome. In this explainer, we're going to tackle a really common GCSE computer science question and show you exactly how to nail it. So, do you find trace tables a little bit tricky? Well, you are definitely in the right place. We're going to walk through one together from an actual exam paper, taking it one logical step at a time. Okay, let's get right into it. What we're looking at here is question 9B from the OCR J277/02 paper. And yep, it's a classic trace table problem. So here's the setup. On the left, you've got the algorithm itself. It looks like it takes a javelin throw distance and a year group, does some checks, and then spits out a score. And our job? We need to trace this whole process using a distance of 14.3 and a year group of 10. Simple enough, right? All right, first things first. With any trace table, you always start by plugging in the initial inputs from the question. So let's get our table set up. Okay, let's fill this in. Line 01 is where the algorithm gets the javelin throw. So let's pop 14.3 into that column. Then line 02 grabs the year group, which is 10. And just like that, our starting variables are locked in. Okay, variables are set. Now for the fun part. We start walking through the code's logic, starting with that big if statement on line 03. So line 03 is our first hurdle. It's asking, is our javelin throw, which is 14.3, greater than or equal to 20.0? Let's figure that out. Nope, that's a false. 14.3 is definitely not bigger than or equal to 20.0. And what does that mean? It means we totally skip the code on line 04 and jump straight down to the next check, the else if on line 05. Okay, on to line 05. This time, the code's asking, is 14.3 greater than or equal to 10.0? What do we think about that one? Yes, that one's a definite true. And because that condition is true, the program's going to execute the code inside this block, which we can see right there on line 06. So, line 06 sets our score variable to 2. Let's get that into our trace table right away. And this is super important. Because we found a true in this if-else-if chain, we get to skip the whole else part. We just jump right over it, past the end if. And that was a really key step. We've navigated that first block of logic and given our score its first value. You know, if we check the official mark scheme, it says exactly that. Score set to 2 on line 06. So we know our step-by-step trace is spot on. Awesome. First logic block done. Now, let's move down the algorithm to the next if statement, kicking off on line 10. Okay, so now the code is checking the year group. Is our year group, which is 10, not equal to 11? And yeah, just a quick reminder, that exclamation mark with the equal sign means not equal to. And yep, 10 is definitely not equal to 11, so that condition is true, which means we have to run the code inside this block, which is on line 11. So what does this line do? It takes the current value of score, remember it's 2, and it multiplies it by 2. The result, which is 4, gets stored right back into the score variable. So it basically overwrites the old value. Time to update our table again. On line 11, score gets a new value. The old 2 is out, and the new calculated value, 4, is in. No, this update is super important. We didn't just assign a score from scratch. We actually changed an existing one. And if we check our work against the mark scheme again, what does it say? Score set to 4 on line 11. Perfect. We've traced that modification correctly. All right, we've worked through all the tricky logic. We are totally in the home stretch now. There's just one final line of the algorithm left to deal with. And that's line 13. It's a simple print command. It tells the program to output the words the score is, and then whatever the final value of our score variable is. And there you have it. Our complete trace table shows the final output on line 13 is the score is 4. Because we followed the logic step by careful step, we landed on the exact answer the examiners wanted. And hey, the official mark scheme confirms it. Job done. So what's the real point of all this? Honestly, it's not about javelins. It's about having a rock-solid method. If you trace each line, one by one, and update your variables as you go, you can solve any of these questions. It doesn't matter how complicated they seem. Just remember this 4-step plan. Step 1, set up your variables from the inputs. Step 2, work through that first chunk of logic. Step 3, tackle the second logic block and make sure you're using the updated values. And finally, step 4, write down the final output. That process right there, it's your guide to the right answer every single time. So I'm going to leave you with a final thought. Now that you've seen the right way to do it, can you spot the common traps?
Where could someone easily mess this up? Maybe they misread the greater than or equal to and think 14.3 isn't big enough. Or a really common one, they forget to double the score in that second if statement. Seriously, thinking about where things can go wrong is one of the best ways to make sure they go right for you.